So everybody got question part A right. For part B, they're asking us to revolve that area. Now remember, it's this area here. We'll revolve that around that line, y equals x. Or I mean, x equals -1. So what I'm seeing is, and what they set up here is they set up washers with regards to y. And so what they did is, and you can see what they did. They took your two equations, y equals the square root of x, and then squared both sides, so y squared. And then once they solved both those equations for y, they said they wanted to make sure they just used washers. They didn't say that, but that's what they're doing. And so let's see, the outside, the top curve is the y equals 3x, so that's why they went, and then because they had to add on that extra 1, because that's x equals -1, so they wanted to add, that's why they went 3y plus 1 is the distance of that radius, and they squared it, times it by pi, factored out the pi, and then they said y squared, because y squared plus 1. And then they said, here's their outside, pi r squared minus pi r squared, and that they did that. Now, I did this differently. I chose to do this using washers. Not washers, but shells. Sorry about that. So what I did is, let me get it. And they aren't gonna test you on shells, but you can do this with shells, and I almost think it's easier to do this problem with shells, as we did when we did it in the book. So here's that line, y equals x. So where I've got is, that's the height of that shell, of that cylinder they were splitting off. So it's going to be what, the square root of x minus 1/3 x, and the dx is the thickness. And then what you got to worry about is the radius. So the radius is going to go from that x equals -1 line. So what we have is x plus 1, or 1 plus x, I think I wrote it down, times 2 pi r. So that's 2 pi, and there's the radius. So then what I did to set this up, let me move this around so I can write something else here. So I did the integral from 0 to 9, or no, from -1 to, no, it's from 0 to 9, because that's where the cylinder starts. It just would be revolved around -1. So from 0 to 9 of 2 pi times 1 plus x times the height, which is the square root of x minus 1/3 x times dx. And then of course you can bring the 2 pi out and then just F and int that. So that's what I did when I solved that part. For part C, because you're building because we're building squares that are perpendicular to the y-axis, we're kind of stuck. We have to do this with respect to y, and that's one reason why if you look at their work, they set it up from the get-go. So what we have is, we have what, x equals y squared. You have x equals 3y. So we've got that side of that squares that distance there, so that's why they said 3y minus y squared. And then because they're building squares up like this with the same height, they squared it. And from 0 to 3 could be because they're doing this with respect to y, not to x. That's how they went this squared. Okay, so I hope that helps you see that. Maybe we'll look at another one before the test that's like this. So for the other version of this quiz, here's the graph that's being shown, and If you find the intersections, you see it, they intersect at -3 and at +3. That's why they're saying plus or minus 3. And then we're doing area of r. Well, r is that top function minus y equals 2. So there's the function minus 2, and they're integrating it from -3 to 3. So pretty straightforward. Almost everybody got that right. So over this next part, what we have is washers. We're rotating that around the x-axis. We get a hole in the middle. So the outside radius is going to be the whole thing from the x-axis at the top of that function. So there's the outside radius squared minus the inside radius, which is 2 squared, and times pi for each, and they brought the pi out, and then they just integrated it from -3 to 3. So fairly straightforward. Not many of you got it right, but it's fairly straightforward. This last part, we're building semicircles like this. So area of a circle is pi r squared, and of course we're going to divide it by 2. But what's r? So r is going to be the diameter is going to be that 20 over 1 plus x squared minus 2, which is the bottom. And if we're looking for the radius is just half of that. So if you look at their work, you'll see that they didn't bother simplifying that too much. What I did when I did this problem is I actually multiplied through, distributed the 1/2 through, so I got 10 over 1 plus x squared minus 1. And it doesn't matter, you can do it the same way, either way. So then we're going to integrate it from -3 to 3, and we've got pi times the radius squared. Then I'm going to divide it by 2, and then we're going to dx. And then what they did is they just factored out the pi over 2. Okay, and I don't have to worry about the 8 because I've already taken care of this 1/2 issue. And then just integrate that, f and int that, and you got it.